Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. Remember the topic is still effect of an electric current on substances. If you remember in our previous lesson, we were discussing the electrical conductivity of molten substances. And we're saying that in molten substances, which includes ionic compounds like lead to bromide, lead to iodide, sodium chloride, that those substances conduct electric current, and the particles responsible for conduction of electric current in those substances are mobile ions, and those substances can only conduct electric current when they are in molten state, but in solid state they cannot conduct because their ions are held together in fixed positions by the very strong electrostatic forces of attraction. Therefore, you need to melt them first, and melting is now weakening the electrostatic forces of attraction, which are now holding the ions of these compounds together. Again, we talked about an electrode, and we said that an electrode is that solid conductor that transfers or that moves electric current into solid non-metallic substances. And again, you see there are two types of electrodes. We have the anode, and we also have the cathode. The anode, we said, is that electrode which is connected to the positive terminal of the power source, while the cathode is the electrode connected to the negative terminal of the power source. And we say that graphite is mostly used as the electrode, and this is because of two reasons. One, we think graphite is unreactive, and second, graphite is cheaper compared to other materials. In this lesson, we are discussing, or we are going to learn about electrical conductivity of substances in aqueous state. And the question we need to ask ourselves, do all substances conduct electric current in aqueous state? Or which substances conduct electric current in aqueous state? Which substances conduct electric current in aqueous state? We will be answering that question in the course of our discussion in this lesson. Just like in electrical conductivity in molten substances, we will have a diagram. That is a simple setup we're going to use to explain how substances conduct electric current in aqueous state. Aqueous state just means in solution state or solution form. They are in solution form. And in this case, we are having copper 2 sulfate, but other substances which can be tested include this. We have sodium chloride, copper 2 chloride, those substances can also be tested, or you can prepare solutions of those substances and test whether they are going to conduct electric current. And when they conduct electric current, then you expect that this bulb is going to light. Other than a bulb, then we can also use an instrument called the ammeter. And ammeter, it is just an instrument that measures the strength of an electric current in amperes. An instrument used to measure the strength of an electric current, and is measured in amperes. You can either use the bulb or the ammeter to show whether there's flow of electric current in these substances. Therefore, in our case, this case, we have copper 2 sulfate and sodium chloride, copper 2 chloride, hydrochloric acid, sulfuric acid, sodium hydroxide, ammonia, urea, and sugar. Those ones can also be tested to see whether they conduct electric current. When substances or when ionic compounds, or when you prepare solutions of ionic compounds, remember to have copper 2 sulfate solution, then you had copper 2 sulfate salt and water. Therefore, this water is just ionizing the ions present in this copper 2 sulfate. Then when you add water to copper 2 sulfate and stir, then you will have ions in that solution. And these ions are going to conduct electric current. For example, if you have copper 2 sulfate solution, then the ions present will be, you will have the copper ions. Copper ions will be present. You will also have sulfate ions. Those are now ions of copper sulfate. But now because you've added water, there are also ions. There are hydrogen ions, and you have hydroxide ions. Therefore, those are the ions which are present in this solution. We have copper ions, sulfate ions, hydrogen ions, and hydroxide ions in copper 2 sulfate solution. And therefore, these ions, they conduct electric current. And the way they conduct electric current, the positively charged ions, they move towards the negatively charged electrode. And therefore, we expect positively charged ions. These are positively charged ions. Will now go towards this direction, while the negatively charged ions will go towards this direction. Negatively charged ions, remember, are called anions, while the positively charged ions are called cations. And therefore, we expect that anions which are the negatively charged ions migrate towards the anode. They migrate towards the anode. Remember, the anode is the positively, or is the electrode connected to the positive terminal of the power source. That is the anode. Therefore, at the anode, we expect the anions which are negatively charged. So the negatively charged ions, they go towards the positively charged electrode, while the cations are the positively charged ions. Then the positively charged ions, they migrate towards the cathode. They migrate towards the cathode. In our case, these two, the copper ions and hydrogen ions, these are cations. They are positively charged, while these two, these are anions. They are negatively charged. And therefore, these cations, we expect them at the cathode the anions, we expect them at the anode. They are going to migrate towards the anode. That is what happens in electrolysis, which again we are going to discuss in our next lesson. Therefore, ionic substances conduct electric current in aqueous solution, because when these ions move to different directions, when the positively charged ions are moving towards the cathode, while the negatively charged ions are moving towards the anode, then electrical, or this movement of ions, it now cause the electrical conductivity, and the bulb is going to light. If it's the ammeter, they're now going to see the deflection of the ammeter. And therefore, copper 2 sulfate solution conducts electric current when in solution form, because this ionic compound, when you add water and stir, then the substance will dissociate into ions, or the ions will now become mobile, and this movement of ions or the migration of the ions on different electrodes, then that is now what is going to conduct the electric current. So many substances conduct electric current. Sodium chloride will also conduct electric current in solution form or in aqueous state. Copper 2 chloride, hydrochloric acid, sulfuric acid, sodium hydroxide, and ammonia, they will conduct electric current, just like copper 2 sulfate, when they are in solution form. Therefore, we expect that these substances, they conduct electric current in solution form. When you have these substances, you add water to them, then you will have the positively charged ions and you will have the negatively charged ions, and that migration of the negatively charged ions towards the positively charged electrode, and the migration of the negatively charged ions towards the positively charged electrode, then that movement will conduct electric current. And all these substances are capable of doing that. But these two, they do not conduct. Both in solid or both in molten they do not conduct. Urea and sugar do not conduct electric current, both in solid, molten, or aqueous state. And this is because they are molecular. They are molecular in nature and lack charged ions. They lack charged ions. And therefore, if you prepare their solutions, then if you replace this copper 2 sulfate with a solution of sugar and a solution of urea, then both are not going to light the bulb because they lack the charged ions. And therefore, they are poor conductors of electricity, both in solid form, in molten state, and in aqueous state. Therefore, that is what you expect. All these substances will conduct electricity because when you add water to them, then water will ionize these substances, leading now to formation of ionic, or leading to formation of charged particles. And these charged particles, they are mobile ions, and these mobile ions are now the ones which are conducting electricity. Therefore, that is what is happening in aqueous states. Therefore, you need to understand that. But maybe to go back to a little bit of what I have said in this lesson, we are discussing electrical conductivity of substances in aqueous state. Aqueous means solution form. So if you have a solution, then that solution, if that solution has ions, then the movement of ions on either direction, the positively charged ions are called cations. Then cations migrate towards the negatively charged electrode, in this case, which is the cathode, which is connected to this negative terminal of the power source. So this is the cathode. Then at the cathode, we expect the positively charged ions, and in this case, they are the copper ions and the hydrogen ions. Then this is the anode because it is connected to the positive terminal of this power source. If they are connected to the positive terminal of the power source, then we now expect, in this solution, we expect the sulfate and the hydroxide ions at the anode. So that is what will happen. Therefore, the bulb is going to light because of that movement of ions on either direction, on either towards the cathode and towards the anode. And then sodium chloride, copper 2 chloride, hydrochloric acid, sulfuric acid, sodium hydroxide, and ammonia, those substances also conduct in aqueous or solution state. Because once you form solutions of those substances, then you'll have the negatively charged ions, or you'll have the anions, and you'll have the cations in that solution. And the movement of those ions in either side, in either the cathode, that is now for the cations at the cathode, and for the anions at the anode, then that will now cause electric current to be conducted. And we have said that there are two substances which do not conduct electricity. In this case, we have the urea and we have the sugar. But these two, they do not conduct in solid, in aqueous, and also in molten state because they are molecular in nature. Being molecular just means that they lack charged particles, or they lack charged ions which can conduct electricity. Therefore, generally, the particles responsible for electrical conductivity in aqueous state or in solution state, they're also mobile ions. Therefore, mobile ions are the particles responsible for electrical conductivity. I hope you understand that. Therefore, that brings us to the end of our lesson today. And I will leave you with this assignment. The assignment is state the particles responsible for electrical conductivity in aqueous sodium chloride. State the particles responsible for electrical conductivity in aqueous sodium chloride. Ensure that you've done that before we meet in the next lesson, which we will be discussing electrolysis. Meet you in the next lesson.